Пустить стримчанс. Так. Все, мяу-мяу. Ну хорошо, орет, все отлично. Эти проблемы стримчанских. Угу.
То есть сегодня мы не можем задать вопрос?
В смысле, ты здесь?
Нет, типа QA session завтра.
Это уж... Смотри, QA-сессия мне нужна для того, чтобы отметить, что они пришли на пару. Вы здесь нормально учитесь, как здоровые люди. А, мы без техники на паре, если что. Только если ты пишешь в заметке в яблочное рабство. Ну, вот, да.
Я просто здесь буду писать.
Ну, я имею в виду, если ты пишешь в планшетик,
Да.
то... Приветик. Ну, сейчас я все объясню там. Нормально. Все, стримчик идет, да? То есть все нормально, все, не очкую. А то мне хватило. Что к другому тее прилетело 60 человек. Что к другому тее прилетело 60 человек. Вот как ты свой голос слышишь. Соответственно, пишешь на той доске и вот здесь. Вот, ну тоже вот здесь. Давай со второй парты на первую парту. Нормально пацаны на первой парте. Что, у вас пара сейчас начинает? Это у вас была какая-то пара до этого? А не, у вас же это сон.
Да.
Да. О, наконец. Добро. Садимся на первую парту, у нас мало все равно. Ой, это что за новые кружечки такие? Это оно буткемпе выдавали?
Нет, да.
Вот за него.
А.
Были позавчера.
Нормально. где остальные? Кто у вас староста?
Я. Но остальные или как бы иностранцы,
Понятно.
или еще
Ну, только Труслав может быть старостой, я понял уже. Ай. Напишите там, что мы начинаем через 2 минуты, чтобы там кто-нибудь активизировал. А ты уже выключил телеграмчик. А первую парту вон сюда садись. Привет. Что, кого-то еще ожидаем или...
Да, это мы что?
Ну, я вижу, армия подтягивается. На первую парту.
Высокие все легкие.
Да, у нас все на первую. Тут место, ну, по крайней мере, тех хватило места. А, видимо, вам нет, это... Отсюда уже будет не видно, поэтому, видимо, на вторую будет. Отсюда не видно. Нам нужно это или сейчас? У вас побольше будет. Do we need to wait for somebody? No. Okay.
Yes. Кирилл.
So let's begin. Today our first lab, and there is our agenda for today. Actually, you already wrote all the, you already read and probably solved most of the tasks, so you know this part about introduction. First of all, I want to know who you are and where you're from. And actually, one sentence about you. For instance, I like anime, or I know I drink Coca-Cola and coding on C#. It's up to you. So let's start from this part. So, your name, where you're from, and one sentence about you.
I'm Anastasia, I'm from Tomsk. I like snowboarding.
Oh, fine.
My name is Zhenya. I'm from Cheboksary, Chuvashia. I'm keen on sport.
I'm Vova, I'm from...
Which sport, sorry?
Different sports, running, swimming.
I'm Vova, I'm from Chelyabinsk and I like basketball.
I was in Chelyabinsk on the mountain farming.
My name is Anton. I'm from Saratov. I love anime.
Fine.
My name is Sergey, I'm from Chelyabinsk. I love swimming.
I'm Ilya, I'm from Kazan, I like programming.
Programming is no. Everyone likes programming. Say something more interesting.
Especially backend programming.
Oh, wow. I prefer like Titans during my class. I don't know. Okay. By the way, we are not using except if you make notes in laptop. In this case, we won't use phones and so on. Not because I am so strict guy, because even I was a student, and actually I am a student, and I know that even if you about online education, I had a philosophy class. After 15 minutes, I just open the Steam and play games. Even the class was not so bad. About phones, even if the class very nice, and when you see that something is not so well, probably someone didn't get what's going on, you just open the phone and start to do anything, and you lose the track. It's the reason why we're not using phone and other devices in our class. Only this reason, nothing else. Okay.
So I'm Захar, I'm from human. I like robotics, reading and writing.
Okay. Nice. Cool.
Okay, and my name is Inara. I'm from Lithuania. I like drawing.
Interesting.
My name is Makar, I'm from Singapore. I like Moscow.
My name is Mikhail, I'm from Moscow region. I like
From which part? I'm from Moscow.
from Krasnodar.
Oh, I know. It's okay.
I like playing piano.
Okay. See, at least someone should provide me good plots. And okay.
My name is Andrei, and I'm from Andrei Shishune, and I like mechatronics and robotics too.
Mechatronics. Okay.
I'm Peter, I'm from Ivanova.
I'm one of Joey. Right.
Ah, I see. Sorry.
My name is Final. I'm from Serang, another project, and I pretty much everything related to technologies, and I especially like to solve Rubik's Cube.
So the previous group was mainly from Kazan. Now we have more interesting group, and a lot of people from robotics. It's nice. So some words about me. So my major was in Bauman State University in Baumanka. I finished with honor degree with Krasny diploma. So my track was CAD developer. So SolidWorks, Siemens NX, and so on. And I know how to program it. So after this, my master was there, and also I'm PhD student, PhD student here. Also, and I'm leader of this club, or RAGE club, Тренируйте и Играй. So also I'm program manager on robotics track. Actually, Nastya is also as a TA. She is a program manager on the first and second years. So we have some questions or problems regarding to either quality of education, maybe some other stuff. You can ask either me or her. It's not a big problem. And also I'm junior research fellow. So a bit advertisement. So you can visit my club and also sport dance because I don't have a partner. And today we have a class. You can go and dance with me. Okay, because I used to dance with a large stick because you stay like this, and I don't like it. Dance with a girl. Okay, so now let's go to the linear algebra. Actually, as you get, I'm from robotics, and I use it a lot. For instance, the first case is my robot, also Robot Zeros. It was my master thesis, and also it's my PhD thesis now. It's a subterranean scouting robot. So I use it for this task. Actually, you may see at home. I use reinforcement learning to help my robot to move, to make locomotion. So actually, he is flying away now because of physics. Actually, I use it for optimization. So I use projections, of course, matrices, vectors to code. So also it's related to DS, I mean data science, of course, because reinforcement learning is something between robotics and data science. The next place is CAD systems. Actually, we can divide CAD systems, roughly speaking, into big parts. It's solid modeling and surface modeling. Who have heard about splines? Okay, only one of you. So spline, actually, we can call it like a curve, which we like this, and it have a lot of interesting properties. There are different splines like NURBS, B-spline, Newton spline, and whatever. Actually, it appeared in 15th century when the shipcrafters decided to make the very nice and smooth shape of the body. So how it works, how it look like? So they put some brick pillars. After this, they make the bench wet and just bend it and receive some. After this, they fix it and they receive some spline. And also, after when it become dry, it will become a curve bench. Branch, yes. Like this. So it's a curve this time. And you cannot, actually you can, but it will be much more difficult to make this shoe using just solid modeling. Solid modeling in terms of solid bodies like, I don't know, you cannot make 3D spines actually. It's about solid modeling. Also, all cars, I mean, you have this smooth array, I mean, smooth, how to say, shape of the car, all this guy. And the last question, actually, you need to think. Now I'm also TA on theoretical mechanics. And I'd like to ask you, so you may see this mechanism, try to understand how it works. And after this, I ask you one question. It's folding bar. Okay. So, who have heard about kinematics? In kinematics, actually, we want to find position of something regarded to something. In our case, it's one goal, so 1 degree of freedom. So we have actuator there. Actuator is motor, for instance. It rotates. So we know these angles each time. And for our case, we want to, we of course know all lengths because we assembled this, but we want to find the position of C regarded to phi. Now you have 3 minutes to think, how can we do it? There are several approaches. You can provide you any field suggestions, doesn't matter. Just now, sit and think how you can solve it. Because it's regarded to linear algebras you can get. And you can solve it even now using your knowledge. You may try to draw something, to think. Don't hesitate to use everything for this. So any suggestions?
We can find it's as a sum of vectors AB and vector BC.
Okay, nice solution. Yes, one of them called like a vector approach. So what else? Now you wrote it in vector. Okay, like again, AB plus BC. Okay. And we can find AC in your case, yes? What else? Actually, we can expand it, and you may get that you don't have enough equations to solve it. Because you know only one angle. And if you write the sine and cosine rules, you won't find it so easy. You need to add something else.
First we find the sum of AD and AB and get
Yeah. Another equation, AD plus DC equal to AC. Now we have 4 equations and we can solve it somehow. Do you get why we have 4 equations? Because we can expand it to the basis. We will cover it later. Okay. It's one of the approaches, vector approach, really nice. And for more complicated mechanism, it's one of the easiest way. But the problem is that you cannot solve it using MATLAB sometimes. Why? Because of roots. I will explain it a bit later. You will see what I'm talking about. Did you see other approaches now? Okay. The another approach is the geometrical one. Actually, I had a problem that I had one coursework and I couldn't solve kinematics for one robot about 2 or 3 months. Because MATLAB didn't solve it because of roots. And actually one guy told me, okay, it's just intersection between sphere and line. And when I wrote it, I found the solution in 1 hour. You can think in terms of intersection between lines, circles. And for this case, see, it rotates. But we can find this B easily because we already know this angle. And the cosine sine rule is easy. So this guy, it also rotates. We know this position, we don't know this one. But it also rotates. So we can find intersection between 2 circles. One circle in B point and around D. And these 2 guys should receive 1 root. So we can write it. Actually, we will receive the same. We will receive the same math as this way. But in some cases, it will be easier. So we can write it xc minus xb square plus yc minus yv squared equal to vc squared. Because it's and the same one for xc minus d squared plus yc 1d. I'm writing in this explicit form because some guys told me, Oleg, we didn't get what's going on there. That's it. And we have two variables and two equations. Of course, we have square there, so we will have two rules. And when we have when we can imagine how our mechanism works, we can choose these precise rules. Because, for instance, in one case, we will have minus x, and we know that we don't need this rule. So when we will try to solve it in vector form, it's not so intuitive, and the problems can appear. So in this case, yes, we can use either geometry because we have EAGLA, so linear algebraic geometry, or vector form. So practical case for your knowledge, which you will receive soon. To sum up, I want to show you, it was my speech, about that. First of all, I widely use all these topics, and actually, as a PhD student, you have to teach someone. As you get, I'm a third year PhD student. So my first time was in linear algebra. It was my first course where I was a TA. It was 2 years ago. And I chose it because I know that I have a lack of knowledge in it, and I decided to improve it. Now I can say that I know this domain. I mean, not know maybe, but at least I can solve all your home tasks. Previous year I went to my to the lecturer and helped me. So that's it. Also, it's not useless. Actually, there are several guys who want to be in robotics, so you may get it. It might help you. And not only robotics, game development, in data science too. And I am very practical oriented guy. So I mean, we have Nasi, another TA. She finished. I mean, she passed exams in math faculty in Kazan University. So she's really math oriented guy. She knows theory well, but she cannot provide examples nicely. I'm another guy. I know practical part is good, but theoretical part I'm not so good. So if you have some questions related to the theoretical part, you can easily just watch her videos, and maybe she will explain it better. So don't hesitate to use both resources, because you can do it actually. So, and intuition, I mean, for me, it's better to explain on numbers or on fingers instead of, oh, okay, it's like, see this, okay, vector, okay, but when I look at this first time, oh shit, I didn't get what's going on there. Because, okay, there are some numbers, but we are going further, you may get that it's not so nice. So, these three parts that I want to say. Also, about how you can call me. It's related to Russian mainly. You can call me either вы or ты or my master. It doesn't matter for me, but our conversation should be efficient. So it's the main goal. You can call me as you want. About cheating. As for me, it's also a skill which you can improve. But if I found you and I found that you're cheating, you should, how to say, be responsible for your deeds. Is the reason. So many people can say, no, cheating is bad. It's not bad. It's also some skill as other skills. So I just worry about it. But I'm not so strict as Nastya. But Nastya is also TA, so she may destroy you if she understood that you cheated. Okay. Now let's go to solve tasks. When I'm talking about tasks, actually we will have quiz. It's not quiz. It's just I don't know. We can omit this word. Actually, when I have some list of tasks, my first goal, when I want to solve it, I need to find all material, all material regarding to this topic, to know how to solve it. Because, for instance, now I'm 2 hours later, I will teach theoretical mechanics. So first of all, I try to write down all equations which can help me, or formulas and so on. After this, it's easier to solve. The same goal I want to show there. So now we have vector, span, blah blah blah, also basis somewhere else. This is there. And now, could you explain me, some of you try to tell me on layman terms, not like open just the definition and say it by definition. I want to how to you really understand it. So for instance, vector, who could answer? Okay. No. Some strange language is going on there.
Directed segment line.
Segment line. Arrow sounds better for me. You know? Arrow sounds better. Segment line. Because okay. Okay. So how we can represent it on the paper? I mean on the sheet or whatever.
As a sequence of numbers or
Okay,
as
sequence numbers. Like this? I don't know.
Not in this like a column.
Yes, we can represent it as a column. We used to represent it as a column. It's our notation, like this. Also, we can represent it like this. Or in some, let's say, in computer, make it bold. Okay. What actually, this is a good question about length. I think you know what is it? About length in MATLAB, for instance, you can find it using word norm, because there are several norms, and first norm provides you the length of your vector. So norm in your vector, for instance. Yeah, we will have some coding task, and you can code on any languages you want. In robotics, you used to use C++, MATLAB, and Python. So it's my, let's say, basic tools. But you can use whatever you like. What else? So, did you get what does it mean span? You had it in home task, so you should at least try to get it.
Which is a set of vectors.
And set of vectors, fine.
This can be described like
you try to explain me formally. I want an informal explanation.
Set of all linear combinations.
Okay, you use this word. What is it, does it mean linear combination?
It's when we use some vectors and some coefficients to express the other vector.
Okay, now I explain it on fingers. For instance, we have a basis. Actually, we will cover basis a bit later. So, all these vectors will be our span for this basis. That's it. You don't need to think in some abstract way, like it's a set of linear. Yes, it's correct, precisely, because actually it's linear combination could be and this and this and this. But actually, it's our span. Linear independence. Who have heard about determinant actually? Okay, but you need to get that now. About 2 or 3 weeks for me it will be a bit tough to teach you, because I used to use screwdriver to screw the ball, the screws and so on. But now I need to use my finger to do it, because now we don't know matrices, we don't know determinants, dot product, cross product, and most of the tasks can be solved much easier using these approaches. But now we need to be like we need to understand how to do it without. So this is a problem. So, linear independence. Could you tell me? Dinara or Dilara?
Dinara.
Okay, thanks.
Yes. I think that it's the lines that don't lie in some. Okay, it's not pure vector that don't lie in the same line or parallel lines. It can be used like basis in some span.
Actually, yes, linear dependence, you can go in 2 ways. You can just write these equations, and it will be a nice way for this. As for me, equal to 0. Or you can think in this case that linear dependence, yes, it should make, we need to receive a basis actually. So basis in our case, basis can be found as determinant if determinant not equal to 0. So what does it mean determinant in geometrical form? It's a square, or we have high-dimension volume and so on, for your matrix. So if our vectors provide this one, of course it will be basis in our case, because in this case we won't receive this a and b equal to 0. We can check actually this one if we use 1, 1 and 2, 2. It will be on one line. I think it's obvious. If we put it there, and it's linear, I mean, it's system of linear equations, and then can obtain that a equal to b. In other cases, it should be equal to 0. So think in these terms, in geometrical form. It's, for me, it's much easier when it's in 2D case. If you want to go higher, in this case, you need to break a brain. Actually. So what else? It's about subspace. It's not so trivial. We will cover it on the task. Because from the previous group, I get that a lot of mistakes they did.
May you repeat this about geometrical form?
The determinant of the matrix, actually 2 by 2, 2 vectors, it's square of it. If they are collinear, so like this one, the determinant will be equal to 0 because you don't have square there. So as for me, it's much more easier than thinking this term. So let's go briefly. Vector, you know this, you already covered it. Basis, yes, basis is a set of vectors if it span linear independent. So span, as we discussed, is numerous part of vectors, and it should be, it should provide a basis, so it should be linear independent. So linear dependence, blah blah, span. Actually, for solving most of the tasks, except theoretical one, you don't need to think about this. You just need to get what's going on and how to solve it. But if you want to go deeper, in this case, it's better to understand. Subspace. We will cover it soon, because it's not so tough. Oh, it's so easy. Okay, the first task. I hope most of you have solved it. Am I right? Oh, it is. Who have opened the home tasks? Okay, at least some of you. So, we won't spend time on this sheet because it's a task for computers, not for us. Because we just need to put it there, and this there. That's it. If you want to multiply, it will be 2, 4. That's it. I don't see any reason to spend time on this stuff. In other case, it's more easier or more interesting. Okay. Okay. Is it vector or no?
Sum of two vectors is vector.
I asking her. I see you're a smart guy. I want to see also smart girls there. So.
Yes, it's vector.
Why?
Because we can add a vector to another vector and get vector.
Okay, what about 2 then? I see minus. My life didn't prepare me to this. Because according to the rule, I know that we have only multiply and summarize and multiply on scalar. So is it vector or no? Three, 2, 1, answer.
I think it's 0.
And 0, yes, and 0. Is it a vector or no?
No.
Okay, another guy. You know that you know.
That's a 0 vector.
Why? And what about this one? What can you say? Can you write like this? No.
No, just write a plus on the brackets minus a, also vector minus a.
Yes, because we can have another direction. Nice. And 0 vector, yes, we have this 0 vector, and we covered according to the definition, we can do it. Okay. This one, I hope you already understood that it's also vectors, because it's the same. Actually, I didn't get why Nastya put this task to you, but do you have any questions about this? Maybe some tricky questions, I don't know. Okay. So far, so good then. More interesting task. Who can answer? Is it the basis? No. Yes.
Yes, this is the basis.
Why? And what basis of what?
Basis for two-dimensional space.
No.
It's basis for one-dimensional space.
Yes. Okay. Who can? I would like to listen to you. Why? Actually, I will explain it later because many people didn't get this task. So why is basis for one dimension but not for others? And I will after it.
Yes, it's for one dimension.
Dimensions. One dimensions. One dimension. Okay. And why?
Because these vectors are not collinear.
I don't see any vectors there. Okay. Is it the basis?
No.
Okay. Others.
Yes, it's basis for one dimension. Yeah.
Okay. So actually, because we have plus, we just need to summarize and we have one vector.
I didn't know there was plus.
Actually, how we can explain this part? So, in this task, you need to answer on two questions. Is it basis or no? Yes, according to definition, we can use it. It should be linear independent. It's nice. And also, what the dimension will be? If it's yes, it's basis, for which dimension? Okay. For this task, of course, we have one vector actually because it's just summarization, and we can write it like 1, 2. After this, we need to use this rule equal to 0. And yes, you may get it. A should be 0 to solve this task. So it's basic. Actually, one task can be solved using this approach, and probably some of you have solved it. Third task. About this one. Actually, it's just a common orthonormal frame, but now we have length 2 instead of 1. By the way, about basis, you can think in terms of, actually you had a home task about x, blah, blah, something like this. Am I right? Yes.
Prove that every polynomial of 3 or more degree.
The last one expressed it into basis. So, I asked Anastasia, okay, because for me it was a strange task. Why do we need it? Because in math it's fun, we can do it. So I don't know why do we need it in practical case. Yes, in this case we can receive a space, actually 4D space, because we need to represent it in x3, x2, x1, x0. And we will receive this vector, and one point will be the solution for this polynomial on this space. Imagine that for this space, okay, if it destroys this one, it will be 2D space, 3D space. Actually, I don't know why do we need it. I try to find this, the real application because I wrote it in my notes to do it because I'm interested in it. But actually, in my practice, I didn't use it. But when we are talking about basis, we need to think in terms of changing the base frame. In robotics, it looks like this. We have a manipulator, the easiest way. And we want to find this position. Okay, let's assume that we have a mobile robot. It's on some platform. Actually, I did it several times on even hackathon. So, and we have some global frame. We can find the base of this robot using, for instance, Kinect or whatever. So we can find this transformation. And we want to find this to this place. How? We can represent it as a frames and go from one to another. And for this, to use some magic, I will explain in the 4th week probably. Even more, I will give you more advanced technique that you should know. It will be a homogeneous transformation. It provides you to solve most of the tasks like this in one step instead of do some big calculations. So it will be your benefit instead of other groups. Yes, so. And you find this one, AB. Actually, it's also in vector form, as you did it in the folding part, actually. So if you think in this case, it will be easier for you to get the base, just a frame, and we can to change the base, and so on. Yes, in general, we can think in terms of bases, not in the orthonormal one, but in more complex, I mean, in other case, like this, or we'll cover it a bit soon. We can prove some concepts using this one. If you understand this, you can represent it, yes, as a basis, 1D basis, and you can just change alpha and find a new vector. That's it. Yes, you need to just break your brain, and after this, you can do it correctly. So let's go briefly. Is it basis? Yes, for 1D. Is it basis? Yes, for 2D. Is it basis for 1D? Yes, for 2 and 3 no. This is one for 3D. For 3D, yes, for space. For 2D. For 2D, yes, because actually we cannot just drop 0, but yes, we can say that this would be for plane. How to get it? Actually, I will show it. So we have, it's our, let's call it, basis. These 3D lines. We can use, this basis provides us this plane, and we can find any vector on this plane, but we can change it. So, but we cannot go after this, so it's about closure, which you also covered. So it's the solution, phi 1. Yeah, the third coefficient equal to 0, but I mean in general one. And the last one?
One dimensional.
No. It was a tricky question. It's not a basis.
So what is not the basis? Because if it's 0 vector.
Yes, 0 vector is linear dependent to every vector. You can 0 vector doesn't have direction. It can be collinear to each vector. In this case, it doesn't provide the solution because in intuition, if according to the definition, it can be collinear to every vector. So in this case, I mean, when we go collinear, it would be basis. So in this case, 0 can be have a direction linear to this one, and also shouldn't be.
For first vector, isn't this basis for one-dimensional?
See, there is only one vector. A basis is a set of vectors. Our set consists of one vector. Our set consists of one vector. Our set consists of two vectors. You cannot just drop one vector. Yes, you can. In this case, it will be another basis. Okay, this task. Who could tell me the strategy how to solve this task? I hope some of you solve it. Okay, I want to listen other guys. Zahar, did you solve it? Or you just open and close as the most laziest, I mean, as the most students should do? What? Did you solve the task?
Actually,
Okay, why? This is fine, I like others, okay. Did you solve it?
I did, but I'm not sure.
Just say, don't worry, I told you. Don't stay to be dummy. I'm dummy. I can say it in front of camera. And no worries.
I made a vector out of these 2 points. So to get it, you must subtract 1 and 3, so and 4, and minus 2 for you.
So you find the vector, okay, tell us.
next you have to like multiply it by 3 because of conditions.
So we multiply by 3
And you will get like this vector from original plane, and you should move it to starting position. Like
actually, perfect solution. Actually, I solved it in the same manner. So yes, you can solve with no thinking in terminal basis. So as you remember, probably vector is not how to say vector is the same on every basis. So we can just change it. I mean, it does regard the coordinate frame. So when we find the vector as we thought, this one, actually it will be there. Our coordinates will be there. So we can multiply on 3 or minus 3 in terms of situation. Out of this, we need to, so we have one coordinate frame, we have other coordinate frame, and we need to translate it to this. We have equation, if we were talking in general, so x prime equal b minus a x. We know this x, and actually our A is an identity matrix. Actually, it's 1, 1. We don't need to know about it now. It's just nothing. It's 1. And B is our starting point, and we just translate it to this place and found the solution. It's one of the possible ways. Other way to solve it. Yes.
I wrote an equation for the line AB.
Yes, it's the easiest way. Yes, I mean not the easiest, but the common way for you is freshman's. Yes.
And I just wrote two equations using x and y as unknowns.
Mm-hmm.
And I got two equations. Y is equal to minus 3x.
I'm asking about strategy, not about equations for now. Because if someone didn't get how to solve it, we will cover it. If you think that it's okay, just to know the strategy, in this case, we just cover the strategy. Because I don't see any reasons for this task at least to spend time on it. If someone didn't get, it's not a problem, because maybe I'm too smart for this. I'm a dummy, but I may be too smart for dummy for this case. So, did someone get how to solve this task? Zahar, did you get? No. So, could you explain again?
So,
which approach do you want to show? Second one or the first one?
First.
Okay.
So we need to replace our vector.
First of all, we need to find vector because we have on the
Yeah,
coordinates.
of course. We need to find vector AB,
Mm-hmm.
and then we need to replace it and multiply and find points.
Yes. We can find the norm, length of this one, and then multiply by 3. Actually, we can think in this not in terms of only this one, but also in terms of basis. This vector can be 1D basis actually, and we just make a scalar for this and find this point. You can think after this we need to shift it because you can think it not in terms of now I wrote it as it's actually we will cover it because now it will be I don't think that we will get it. But when I wrote the equation, I wrote equations for the vectors, but we can wrote equations for the bases. And in this case, we can, in one side, we will have this basis will be just a vector, 1D basis. So there are several ways to solve this task. One of the solutions, yes, as you mentioned, I mean not you, but the second one. So find the distance, find the equation of the line, find the points, and that's it. Times. The third task. Who have solved it? 1, 2,
Points.
3, 3.5, 3, 4. Okay. But first of all, I'd like to ask, what does it mean gravity center? Because we have a task, but I am sure that most of you didn't think about it. What's the difference between gravity center and center of mass and geometrical center? Who knows about it?
We don't have masses.
In this case, we are talking about this. We can say that we don't have even gravity because we don't have mass. Actually, okay, I can answer on it because I thought that you won't know it. Actually, between center of gravity and center of mass, in our case, it will be equal. In classical mechanics, it's the same. If you want to know more, you can look at this video. Actually, roughly speaking, it will be on theoretical mechanics actually, but we have a mass on some mass, yes, mg. We used to write like this. You used to think that it's one point. We choose one point and make it. Actually, it's a gravity force related to the not one point, but it's spread through the volume of the body. So actually, it should be like this. So, and because in our case, we can assume that the difference between this position and this position will be equal because we can assume that it's a uniformal distribution. Uniformal is just like this, so it won't change according to the line time. It's linearization, let's call it like this. But we are told we have a 100 kilometers bar, for instance, and G on this place, and for instance in Ecuador, I don't know how to in English, we'll have it all in the on the pole. As you know, it will be different because our it's not a ball; it's some kind of. I mean, the Earth is not a sphere; it's like this, and mistaken. Okay, so for our cases, yes, it's the same. But why do we need it? What's the practical case to know this? Why do we need the center of mass? Just
predict something.
What?
To predict something.
What predict? How to when
we launch some rockets to the space, we need to know.
To launch our belly to the canteen and start to eat. So it won't help us. Okay, so about rocket, not bad. Yes. What else?
Distributes mass and finds. Can't say it's in English.
Say in Russian.
Information.
Oh yeah, fine. It's about sopromat. I don't know how to English. Sopromat resistance or resistance of material.
Yeah.
Yes, about bulking. Yes, you can find it. Nice. What else? Robotics guy, you should. I'm expecting great answers. Okay.
Some physical tasks.
Actually, there are several. One of the possible applications. Imagine that you're in a space. You're in a suit, and you want to return to your place. How I can do it? I can just throw something, and because of center of mass, I can return. I mean, you can solve it and find your trajectory when you want to return in vacuum. Another solution is ZMP, zero moment position. Actually, it's for humanoid robot and it's for my robot, for instance. So, roughly speaking, in layman terms, just imagine that we have 3 points, and if my center of mass will be there, I will fall. So it should be the center. Do you know the robot from Boston Dynamics?
Yeah.
So they solved even more advanced techniques than ZMP to catch its balance, because ZMP provides you to solve either for statics. I mean, we can represent our robot locomotion, humanoid robot locomotion, as a static for each time. So one time I can stand, this time I can stand, I can move like this. Boston Dynamics robots provides dynamic balance. So if they stay like this, they will fall. And you can find and know the center of mass of the robot. You can represent it there and find it will be stable or not. In this case, you represent your legs not at the point, but at the rectangular, for instance. And you can take this for points, and this polygon, our center of mass should be in the center of polygon. But the question, how can we find the center of mass? Actually, you don't need to do it by yourself because we have CAD systems. And how it looks like, it's the leg of my robot. This one. So I want to know the center of mass and other properties. I just put one button, and I need to provide all materials, of course, because we're talking about mass. We need to know the mass of my robot. After this, it can show that probably a geometrical center and center of mass. So we have a red and greenish, but point, and we receive coordinates related to some frame. So in CAD systems, also change the basis is quite important, because in some cases for CAM, computer-aided manufacturing, it might be helpful. So for some more complicated tasks, you just need to use computer and don't think about it. But now we are in linear algebra, and in some cases we need to at least get how to solve it. So let's return to this guy. Okay, it's the answer, actually. But let's go to this. How can we solve it?
Just draw the median, the two medians, and calculate their intersection.
Okay, there are three approaches. First approach, just Google how to find center of mass of this. Of course, I did it first of all because I need to provide you this solution. These numbers. I just imagine it. Okay, I need to find a good solution, and I found the equation: x1 plus x2 plus x3 divided by 3, and we will find center of mass for A. And I don't need to think. The first way, and of course for Y, the same. Then I found the solution. As I told you, you need to think how to solve in the easiest way. You don't need to think sometimes. You just need to Google. Well, yes.
Now we can draw a triangle, then find the median point of one length.
It's if you know the property of the median. Yes. If you know this, you can solve it the same way. Because of course you already Google it or you know about it that the center of mass for the triangle will be the center of medians. But for instance, for some other figures it won't work because it have another ways. So also we can think about symmetry and other stuff. There are several approaches. The easiest way for our case actually is the same task, but one with with numbers, other with just vectors. If you write it in this manner, so we draw the plot. O, A, B, C. We can rewrite it in OA plus OB equal CO. We just put it on the side. And in this case, you cannot use minus. We can, but actually it's better just to rewrite. How does it look like? OA, OB. What will be the answer? Yes. So our answer OC, I mean, if we write M plus IC, it should be equal to 0. We should receive 0 vector. So it should be equal. And if you put number there, you will solve, and you will find this O. But the question is, can it be outside of the triangle?
No.
Why?
If we put some point outside triangle, then we can draw one x-axis as a part of the triangle and then y-axis, and all points of triangle will be on positive side of this plane. And if we draw summation of some vectors and all of their coordinates are positive, we wouldn't get a 0 coordinate.
Actually, yes. In intuition, we can think another. Okay, let's put the number, this point there. Oh, okay, even not there. There. And we do it again. We receive some then it's O. How can we find this O if they are not actually collinear, or even if they're not collinear, they look in one direction? We need to receive 0, they should look in another direction, but in our case, it looks in one direction, so we cannot solve. I don't know, will it be proof for the mathematician guy, but as for me, as an engineer, it's okay, because now I cannot provide other solution. And you can think another way. Okay, I just wrote this equation, found something. But we need to put constraints. Or at least we need to check, is it inside this triangle or not? What approaches can we use to get, is it inside or no? Again, there are two ways, at least. First way, you just Google and find this equation. It's a big equation, linear system of linear equations, and the usual put this number you will get. Another way to think in terms of bases. Let's think. Let's make AB, let's make our basis is AB and AC. It's our basis. So, of course, let's write in this manner then. It will be theta AB plus, for instance, gamma AC equal to 0. So what the properties do we need to put there that it supports? So that, our point should be inside. Okay, I give you the first hint. So, for instance, for AC, it should be from 0 to 1. Because if you put the point there, it's more than 1. In this case, it's completely out of the triangle. If you put -1, it also. Of course, do you get how to get the coordinates for this basis? Actually, you have coordinates. You can find vectors. We need just to put it to 0. So we just need to vector minus a point. In this case, it will be equal to 0, and we start from the spot. Okay. The second hint. The second. We need to find two Morse constraints.
Can I ask a question?
Yes.
If these vectors are bases, they are linearly independent.
Yeah, sure, you may check it.
But you will say that gamma should be 0 or 1. But if it's linearly independent, they must be only 0. No?
It's if you want to find vector point, it should be 0 in this case. Because how you will find the vector? Actually, vector is this plus this equal to something. So, but you're right. Thanks. So, guys, don't sleep. Okay, next hint. What about this guy? Should it be the same or no? Why you didn't say that? And the last one, the most important. Future project manager for EAGLA1. What the answer?
Maybe half 1.
What, half 1? What do you mean?
1/2. I don't know how it's in English.
What do you want to say? Say you're like Vova, okay. Say in Russian.
Типа, нам же нужно число найти.
Не, нам нужно сейчас. We need to make constraints that our O coordinate. We can represent AO as a vector. So we need to provide this solution that AO should be inside the triangular. And we write the properties. Actually, we can code it easily and check it. Where did you, let's say, lose the track? What you didn't get?
So we can make.
So, okay, let's explain again. We need to find actually AO, and we want that AO should be inside or outside. We need to check it somehow. Now we try to find its constraints will help us to get it.
So we can make space by B, A, and C, and check if O in this space.
What do you mean? Actually, what we are doing now, we can make bases.
Yeah.
So it will be this one. It's our basis.
Yeah.
I mean, we'll find span. Yes. Now we need to restrict it somehow. Now we know that if let's say is it equal to 1, it could be there because in this case, in any case, despite of another component, will be outside the circle. Also, we know that it shouldn't be negative. Okay, the super pooper thing. This point. What it will be? It will be 1 plus 1. Of course, I think it's out of this triangle. So what do we need to do? That it should be inside triangle. Now you have all needed information.
Our sum of scalars must be
For a
1.
less than 1. Less or equal to 1. Yes. Congratulations. It is because in this case we will finish there on this plane. Nice. So yes, we solved it. In this case, now we have this one, and we can check that it's out or on. And after this, actually, I will provide the solution later because I had one thought, and we tried to solve it using this approach with previous group, and we found out that it doesn't work. So I need to try again, and I will provide you a solution how to try to prove it using this approach, for instance. Are you with me? It's okay. By the way, about breaks. There are two ways. We have soft break and hard break. Hard break when I would say 5 minutes break, get out of there. The main withdrawal for this approach is that it's not 5 minutes break actually, because you need after this about 10-15 minutes to return to in work position. I mean, because after this you will go, it will be 1-2 minutes plus and blah blah blah. So break you just need to change activities. So now we discuss after we solve something. Also we'll watch videos. Today I already spent a lot of time to speak about that I'm the best man in the world. Next slide we will watch some funny videos, probably some encouraging videos for you. We'll explain some extra topics. So it will be our soft break. Or I can throw marker to your face. Okay, blah 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 blah. This solution, of course, you can just draw it and find. So I do it in boom 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 and find the solution. Center of medians, yes. Again, if you can solve using one approach, solve using another approach. That's it. Be flexible. The last one, if not mistaken. Нет, not last one. The pre-last one. What does it mean, component? Yes.
They lay in the same plane.
In 3D space, in same plane.
Same or parallel.
Determinants of their.
We cannot use word determinant now, but we can just do what? We can just, okay, Google, what does it mean, complanar? Complanar vectors. Bams, and we receive some definition. Blah 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 blah. If the scalar triple product equal to 0, linear independent for n vectors is among no more than 2 linear independent vectors. Actually, you can do like this, and you will get what's going on. In our case, actually, it should be linear independent. So what we need to write? Alpha 1, 2, 3 plus beta 4, 1, 5, and start to suffer because we need to solve this system of linear equations. Or you can use determinant. Actually, we will learn it soon, and you won't suffer. But in some cases, it's better not to do it using this straightforward approach. It's better to think. Yes, we need to try to think, even if Inoculus doesn't provide this ability to us. We can just watch on it and get, will it be linear independent or no? There are two, or I'm saying three, possible ways. First of all, it's alpha A equal to B beta. So, in the best way. So, if you multiply by 2, you will receive the same. In this case, you don't need to solve it. You don't need to write this equation because it's linear dependent. The second way is, it's the most difficult one actually. It's A plus B equal to C, or something C. Actually, it's also the same because C, 1 plus 2, again, this vector will receive this one. This is the best case for this to show, but actually I can provide you a solution where it won't work, that only one will be work. For this case, it will be, for instance, I don't know, 1, 1, 2, 2, 5, 7. In this case, only this one will work. Or 1, 2, 3, 4, 4, 6. Sorry, it won't. So in this case, 5, 7. So this won't work, only this works. It's the most difficult one because it's not so easy to see it. Even if you have, how to say, in this case it's C, but if I write, for instance, 5, 10, it won't be so easy to get that it's linear dependent. But in some cases it might help you because, as I remember, when I provide some quizzes to my students, and I provide really tough with a lot of real numbers, matrices, and they should solve. But they don't need to do anything because it was already the answer. But they didn't check the solution that is it coplanar and so on, and that's it. They just spent 10-15 minutes to solve it, and only two guys said, okay, let's check firstly. They checked, they already understood that it's a solution, and that's it. So it's my advice to you to check. Can you solve this matrix or no? Can it be, because some cases it will be just linear dependent and you don't need to do anything. You just need to write linear dependent, it's not a basis, goodbye. That's it. So, do you get how to solve this task? Two approaches. First approach, you just need to write system of linear equations and solve it. Second way, to use definition determinant, we'll cover it later. Actually, it's about, let's see. And after this, it's our matrix. And after this, you just need to write that, and that's it. And put it in MATLAB or Python, and you will receive solutions.
And you can just calculate the volume of this figure and say, does it equal to 0 or not?
Yes, because as I told you, determinant provides you a square, or we're talking about higher dimension and volume of our, of our plane. In this case, we put 0. If you want, we can solve one of these tasks. Or probably some of you have already did it, and he can just write down it on the table. Did you solve this task?
I solved it in other way.
So, how?
I said that we have 4 points, the region of coordinates and ends of vectors, and if And I checked if they lay on the same plane. I believe.
So if they say because you have 3 of 3, I see. They did like this. So actually, yes, you can check. You can solve either this one. I mean, solve this free linear, or you just need to check all possible combinations. So this is linear dependent on no. This is linear dependent no. This is linear dependent on no. After this, you can say it's a component or no. It seems that you didn't get anything. Yeah. Okay. Who wants to be there? Okay. Zahar, he wants to be. It looks pretty nice. I want that you will be on camera. Okay. Because we have a lot of girls in our online class, so we need to talk a little bit there. And solve the first. Oh, okay. Let's solve the.
I understood that if determinants.
No, forget about determinants. Use linear dependence rule.
Okay. So if linear independence is right, then it's component, yeah?
Yes, no.
The three vectors that can create a three-dimensional space. We need that they're all on the plane.
Okay. So we have first task.
Yeah.
Okay. So may so we have
Equal to 0.
equal to 0.
So rewrite it in system of linear equations.
So
No, you already did it. I mean, now we have 3 equations. Vector is just
Alpha plus 4 beta minus gamma.
oh, lambda, yeah, thanks.
4 beta.
4 beta.
4 minus gamma equals 0.
Alpha, so scalar provided to each of
I
coordinates.
understood it. So then we need to solve it. And that's all.
No. You need to find the solution.
Yeah.
So,
Okay.
you're welcome. You told me that you didn't get how to do it, so. You have 3 variables, 3
Yeah,
equations.
but I find more easiest way.
Except
More
that
easy way.
you cannot use determinant.
Yeah, I understood.
So
that.
now you need to feel that, as I told you, as I feel it now, that I have a finger instead of screwdriver as I used to use.
I hope it won't be on exam, like in this way. I hope it will be in heaven.
It's good.
Well, you will try to solve it. I will check the result. Word.
Okay.
By camera. Okay. Stream. Mm-hmm. It works. These are numbers. Продиктуй, пожалуйста. Продиктуй.
Знали? 1, 2, 3.
Не по строчке.
1, 4, минус 1.
Дальше.
2, 1, 3. 3, 5, 2.
So equal to 0, so it's linear dependent.
But lambda is equal to 0. Yeah, it's strange. It's a bit strange.
So to solve this task, you need to do it really care, and it's better not to do it on the whiteboard because you make a lot of mistakes. It's better to do it on your sheets. Who have solved it? Or just sit?
So we have that alpha is equal to minus 2 multiplied by lambda, and beta is equal to 5/7 multiplied by lambda.
So try to check at least someone that they should be dependent. Just put numbers.
So we can like lambda is equal to 1 and then check. Okay, so minus 2 plus 5/7 multiplied by 4 minus.
Where is your vectors? So see, now you have alpha, so you can put it there and check. So minus 2, 1.
But it's minus 2 multiplied by.
So you can provide. Okay, let's put lambda equal to 1.
Yeah, okay. Lambda is equal to 1. So then it's minus 2
You can write them there.
minus 2 So we can't use determinants. Yeah.
Now we just need to see. Who solved it correctly on the sheet?
Well, first alpha, second minus 5 over 13 alpha, and the third one minus 7 over 13 alpha. If we talk about coefficients before.
Yeah, sure. And you put did you put numbers?
Yeah, no, I can say we can put every number at this variable and get minus 5 over 4, this number, and
Yes.
minus.
Yes. So write down the right solution. I mean this numbers.
Okay.
Alphabet and.
Maybe understood where.
You just made a mistake, I'm sure.
Yeah.
Because it's not so easy. Also, you can find the solution using RF, row reduced echelon forms, or Gaussian elimination. These fancy words will be available for you soon. You need to buy DLC, put likes on my videos, probably I will receive monetization on this, I will steal money. After that, we should put advertisement, not like this, not like today, but some like with legend. Range shadow legends, yes. Because our class from integration. Okay. So there is a solution. You may check it at home. Bam, bam, bam. Okay, nice job. Not really nice, but at least you made some activity on the whiteboard. It's not so bad. At least you clean up the whiteboard. It's the best, best way, yes. Because we need a free space for the last task. Bams! So who have solved it?
I can say the second one is right.
Okay, others.
Oh, third dimension.
Okay.
And
yeah, it will be nice. Actually, I will explain the task in a really, let's say, grounded manner, like for me. Yes, you can solve it in two ways. You need to open this guy, where it is, and we will check it now. So the first task was wherever it is, blah blah. This the plane y less than 0. The third one. Did you get? Let's go to this one. What is it? We have a plane. We have a plane. And this place should be our subspace. Is it subspace? No. Is it? No, what do you think? Why not?
The subspace would be inside space.
We are talking in plane, so it won't be a subspace even for plane. Why? Okay, see, we have these guys. Let's draw one line. One vector. We need to, if we took another vector from this, we should be in this space, in this subspace. I get out of my subspace. So it's not subspace. Because of this rule. Or we can just scale it and also go out of this. According to this rule, because subspace is related, it's inside our subspace, I think you agree. This one too. And the symbolization should be also. And you may see it, it's not.
Can we somehow bring the first behavior. W is the standard like it's getting
Actually, the subset, if we are talking, is it subspace of R2? R2 is a plane. In this case, actually, if you said it's subspace, you already choose who will be on the right side. So the first one. No. Second one. Yes. For plane. What about entire plane for space? Yes. Because space and for plane. Third one, yes. Yes. It's also. I mean, no. Only one is here. My bad. Because circles, it's much easier to find two vectors in a circle which can go out. Actually, that's it for today. Do you have any questions not related to any feedback from today's class? Was I too fast, maybe too slow, maybe I didn't explain something that I thought that is obvious?
Question, but I don't know how to say it in English.
We can solve this task with, wait a second. Goodbye.